All right, would you please solve these three equations? I have the absolute value of 7 minus x is equal to 4. I have the absolute value of 2x plus 1 is equal to 8. And I have the absolute value of x is equal to the absolute value of 2x minus 1. Please pause the video and try those now. Okay, solutions. The solution to the first equation, there's two solutions, 3 and 11. The second equation, 7 halves and minus 9 halves. The last equation, 1/3 and 1. All right, discussion. The key with absolute values is think of it as the distance from the origin. All right, absolute values correspond to distances. All right, so therefore an absolute value equation will be telling you to solve for values of a variable such that a certain distance is a certain value. All right. Now remember that on the number line there are 2 points that are any given distance from the origin. Okay, for example, how many points on the number line are 4 units away from the origin? Well, there's 2. You could be standing on the point that corresponds to the number 4, or you could be standing on the point that corresponds to the number minus 4. Okay? Because there's 2 points that have the same distance, then absolute value equations will often have more than one solution. Okay? Check your answers again by plugging your answers into the original equation. All right? If you need more practice with that regarding this stuff, of course, do lots of SAT math problems that have absolute values. Do lots of problems from your math books, whatever it takes to get comfortable with these. Okay? Now, next topic, would you please solve the following systems of equations? All right, so the first problem, I have 2 equations. I have x plus y equals 4 and x minus y equals minus 3. And then for the second system, I have the 2 equations, 3x equals 4y and y equals 3. All right, pause the video and try those now, please. Okay, answers. The 2 numbers that satisfy the first system of equations, 1/2 and 7/2. The 2 numbers that satisfy the second system of equations, 4 and 3. Okay, discussion. To solve systems of equations, there are 2 methods you can use. You can do what's called substitutions. All right, you isolate one variable, so you'll have x equals some expression, for example, or y equals some expression. Then use that expression and replace that variable everywhere. All right, do you see how that you can eliminate a variable by what it's equal to? Okay, that's the substitution method. All right, another method is to add or subtract equations. All right, you'll notice on the last slide, the very first system, the first equation had a plus y, and then the second one had a minus y. Can you see how if you added the left sides of those equations together and the right sides together, you would get a new equation where the y's canceled out? All right, and then you can solve for x. That's a really clean way sometimes to solve a system of equations. All right. Now, the last system, did you notice how I had already solved for y? All right, so for the second one, you can replace y in the first equation, the expression for y in the first equation of the second system, and that would be a clean way, easy way to solve for x. Okay, the best thing would be to learn both methods, and then you can select whichever is easiest for the problem you're trying to do. Okay? Now, again, I'm a big fan of of easy techniques that give you a lot of value. Remember to check your solutions. Okay, you can see if your solutions satisfy both equations of the system or one. All right, but for goodness sakes, don't not check any of them. All right. Now, would you please solve the following? I have here the inequality negative x is less than 4. The next inequality 8 minus 3x is less than x plus 2. Third inequality 9x minus 5 is greater than or equal to 6 minus x. And then the absolute value of 2 minus x is greater than 5. All right, I'll give you some time now to try these. Please pause the video and then we'll continue. All right, solutions. The solution to the first equation, the first inequality is all numbers greater than minus 4. The solution to the second inequality is all numbers greater than 3 halves. The solution to the third inequality is all numbers greater than or equal to 11 tenths. And then the last inequality, the solution is a little bit more involved. It has two parts, all numbers less than negative 3 or all numbers greater than 7. Okay, let's discuss that now. So the topic here is solving inequalities. Okay, the good news is that like equations, you can perform the same operations to both sides to simplify inequalities. All right. Remember how I said that was the key idea, one of the key ideas of algebra with regards to equations? Okay, remember you have to balance that seesaw by adding, subtracting, multiplying, and dividing the same stuff from both sides. Okay, you can do that for inequalities. Okay, there is one caveat, one warning. Okay, when you multiply or divide by a negative quantity, make sure to switch the direction. That's the main gotcha regarding inequalities. What do I mean by switching the direction? If the inequality, let's say, has a less than symbol, when you multiply or divide by a negative quantity, you have to turn that less than symbol into a greater than symbol. Okay, and vice versa. If you have a greater than or equal to symbol, if you multiply or divide by a negative quantity, you have to change it to a less than or equal to symbol. All right, get the idea, or vice versa. Okay, so please make sure that you understand that. Absolute value inequalities will often have two solutions. Okay, remember I said absolute values had to do with distances. All right, so you can see that if we were talking about an absolute value, let's say being greater than 3, that would pertain to all the points that correspond to numbers greater than 3 or less than minus 3. All right, do you see how there's two regions on the number line that satisfy that constraint on the distance? All right, so please make sure you understand those types of inequalities and do, again, lots of practice problems. Okay? Now, next topic, would you please evaluate the following expressions? These expressions utilize these two function definitions. F of x equals 5 minus x and g of x equals x divided by 2. All right, so pause the video and try those now, please. All right, so what's going on here? Solutions. First one, f of 4 gives 1. The second one, g of 1, gives a half. And then the third one, f of g of 3, is the same as f of 3 halves, which gives 7 halves. And then g of f of 4 is equal to g of 1, which is equal to 1 half. Okay? Discussion. We are now talking about functions. All right. Functions are machines that accept inputs and generate outputs. Okay. Equivalently, you can think in your head, you can have the image of functions as sets of ordered pairs of numbers. Okay. The key idea is that functions associate numbers with other numbers. All right. That's the mission in life of a function. Now, what about if you have stuff like f of g of x? What's going on there is x is the input to the g function. The output of the g function becomes the input of the f function. Okay, and then the output of the f function is the what the expression evaluates to. All right. In other words, if you see f of g of x, evaluate g of x first, and then whatever answer you get there, take f of that answer. Okay.